Hi there, I thought it'd be good to give you a few more negative exponent examples, just to give you an opportunity to work more with them. So example one is going to have several parts to it, but the same directions. And the directions are write the expression using only positive exponents. And again, the exponent only affects what it's next to, so that's something to just kind of file away as you're working on these. So part A, I have 14 to the negative third power. So that negative power tells you that the base is not where it belongs. Right now, if we were to write this as a fraction, 14 to the negative third power is sitting in the numerator. And that negative exponent is telling you it doesn't belong in the numerator. This whole thing belongs in the denominator, which then leaves us with 14 to the positive 3 in the denominator. And what's left in the numerator is not a 0. We hold that space with a 1. You could even think of it as 1 times 14 to the negative 3. That's where that 1 comes from. So negative exponent in the numerator means it belongs in the denominator. Once you put it where it belongs, it becomes positive. Part B, let's say now we have 7 over c to the negative 2. So if we're supposed to write this using positive exponents, we have to move this because the exponent is negative, and negative exponents tell you it's not where it belongs. This base does not belong in the denominator. So we're going to move it to the numerator. And it's just going to sit next to the 7. This becomes 7 times c to the positive 2. And now you can see that it's sitting in the numerator right where it belongs. Once you put it where it belongs, you switch it from a negative exponent to a positive exponent. All right, let's look at one more. 24d to the negative 1. So that negative 1 only affects the d. It is not doing anything to the 24. Exponents only affect what they're next to, and it's only next to the d. So we need to move that out of the numerator. This is telling us, this negative exponent is telling us the d does not belong in the numerator. It belongs in the denominator. And so we need to move it, leave behind the 24. It's right where it belongs. And once we move that d to the denominator, the exponent becomes positive. And you could write a positive 1, and it would be correct. If this were a test, I would not mark you wrong for writing it. But if you were taking a multiple choice test or working on a worksheet that had multiple choice answers, that 1 would not be there. We've talked about this a few times. Mathematicians are kind of lazy, and if we don't have to write extra stuff, we don't. And so we would just leave off that 1, understanding that if you don't see an exponent, it's a 1. Okay, so moving on to example 2, we have a different set of directions now. Now you're being asked to write the expression without a fraction bar. And again, example 2 has a few parts to it. So let's just start with part A. Part A says 5 over t to the 4th power. So if we wanted to get rid of this fraction bar, that means we need to take everything that's in the denominator out of the denominator and move it to the numerator. Right now, this is a positive 4. That tells you the t belongs in the numerator. It's right where it belongs. So if we move it to the numerator, we need to represent that it is not where it belongs anymore. So to do that, we're going to move this t to the 4th to the numerator. And I'm just going to put the dotted over 1 there so we can see that it is the numerator. We really wouldn't want it because we're supposed to be writing it without a fraction bar. But if I move it to the numerator, I need to represent that it really belongs in the denominator. So I am going to change that exponent to a -4. The 5 is already where it belongs. It's going to stay in the numerator. And so what we end up with is 5t to the -4, meaning that this base is not where it belongs. It really belongs in the denominator. And when it goes to the denominator, it becomes positive because it's where it belongs. But our directions said to write it without a fraction bar. So our answer would be 5t to the -4. Part B. If we have 6z over y to the 5th, same thing. We need to get rid of the fraction bar, which means we need to get rid of whatever's in the denominator. This is going to move up to the numerator. When we move it to where it doesn't belong, we need to show that it doesn't belong there with a negative exponent. This is right where it belongs. It stays in the numerator. So now the only thing I would change about this answer is that we normally write our answers in alphabetical order. So I would move the y to the -5 in front of the z because we can multiply in any order we want. It doesn't change the result, but this is what you would see if it were a multiple choice answer. This is the form it would be in. Okay, so one last set of examples, called example 3, and give it a couple parts. Now the directions are telling you to find the product. Write your answer using only positive exponents. Remember, product is the result of a multiplication problem. So we're going to simplify it, and we're going to write our answer using positive exponents. Let's start with one that just has numbers. 8 to the 5th times 8 to the -6. Okay, a lot of ways you can do this. I would emphasize that what we have here is a base that is not where it belongs. That -6 is telling me it really belongs in the denominator. So it would become 8 to the 5th over 8 to the 6th. And then you can see that 5 8s in the numerator are going to cancel out 5 of the 8s in the denominator. So what we're going to have left when we're all done is an 8 in the denominator. Because 8 over 8 is 1. All of these are going to pair up. 8 over 8 is 1. All of those cancel out. And remember, there is a 1 left for each of those. And we need that 1 in our numerator because nothing's left. And you want to remember there is a 1 left in the numerator. And what's left in the denominator is an 8. The other thing you could have done is said, oh, I know that 5 minus 6 is -1. So you could have said it's 8 to the -1 and then recognize that you need to move it to the denominator. Or you could have said, oh, there's more 8s in the denominator. There's 1 extra 1 and what's left on top is a 1. So lots of ways to get to that same result. But if you start with 8 to the 5th times 8 to the -6, simplify it all down, write your answer using positive exponents, 1 over 8 is your answer. Okay, last example. We have 9h to the -2 times 5h to the 10th. A lot of stuff going on here. First of all, remember the exponent only affects what it's next to. You can start by recognizing that the h to the -2 is not where it belongs. It belongs down here. And when you move it to the denominator, it becomes positive. So we're leaving behind in the numerator 9 times 5, h to the 10th. And in our denominator, now we have h to the positive 2. 9 times 5 gives us 45. And if I have 10 h's in my numerator, 2 h's in my denominator, these 2 h's are going to cancel out 2 of these h's, leaving us with h to the 8th power. 10 minus 2, 8. There are more on top, so that's where they belong. So hopefully this is helpful, and the next video we will be talking about 0 as an exponent.